Hello all. We have this problem with us and you have already seen the thumbnail, but let us spend some time on how to understand the problem and how the problem is worded, right? So see, there are two circles. One is of 9 centimeter and another is a 4 centimeter radius, right? Now these circles are separated from each other and they have a common tangent. So how does it look? This looks like this. So this is the common tangent, right? That is the common tangent of the same side. The common tangents can be like this as well, but we are not talking about that common tangent, right? So this common tangent is of the at the same side, and there is a third circle that exists which touches this circle and this common tangent, right? So this is something like that. But here let me spend some time to basically understand how this can be possible. So let us say there are two circles like this, right? Now how many circles can be tangent with them? Like this can be a possibility, right? This can be a possibility. If the circles are further apart from each other, then this might be something a little bit bigger, something like this, right? So if the circles go away from each other, the circle in between them, they get bigger and bigger, right? And it is one key word is there, that is the third circle is in its maximum possible size, right? That means these two circles, these initial two circles, are apart from each other as much as possible, right? So let us go back. So we have this particular circle with us. Now what does this mean? This means if you join these 2 points, and if you join these 2 points will form the diameter. So like this red thing, this is the diameter of the third circle, right? And this diameter of the, like this center of this third circle lies on the on the on the straight line which joins the centers of first two circles. That is the first thing to understand here. Okay, all right. Now what we have to do is, now we have to simply calculate the distance between these 2 points, right? So that is what we need to understand here. Okay, so now we have understood what the problem says. Now we will jump into the solution. How we solve this? Yeah, so yeah, now we have understood. First of all, let us take a common case. If there are two circles, let us say like this. Okay, let me draw this a little bit bigger because that will help you understand it better, right? So these are two circles, let's say. Okay, these are two circles. Now they have a common tangent, so this is a common tangent, right? And let us say these two are the centers. Yeah, now these two are the centers. Now let us say we have again join these two. Now what we know is this is 90-degree, right? The for any circle's tangents, it will have a 90-degree angle with the center, right? So this is also 90-degree. Yeah, now let us join these two. Yeah, this is join these two, and let us do one thing, understand one thing. So these two lines, so like this line and this line are perpendicular to the a third line, the tangent. So that means they are parallel to each other, right? So what we will do is, from this center we'll drop a parallel line here, parallel to which this line. Yeah, so basically this new thing is a rectangle. That is what we are finding out. And let us say that this length of the tangent is L. This is the length of the tangent, right? This is L, right? So it is a rectangle because all these are 90-degree, and we have dropped a parallel line. So this will always also be 90-degree, right? So this is a rectangle. And let us say the bigger circle has a radius R and the smaller circle has a radius smaller, right? Okay, now what is this? This is simply R minus R. Why? Because this is R and this must be R, right? So this must be smaller, this length must be smaller. Yeah, so we have found this is this one. Yeah, and let us have the length of this will be the same length as this, right? So that is L. And let us say these circles are separated from each other by distance D. So what we can write? So we have this particular rectangle here, right? This particular rectangle that I have highlighted. Sorry, this is a triangle. The particular triangle that I have highlighted. This is a right angle triangle again. Why? Because this angle is 90 degree, right? So that is 90 degrees. So that means we can use Pythagoras. So Pythagoras will say L square plus R minus R square, right? That should be equals to D square, right? There should not be any confusion in this. So if you calculate, what we are trying to do is we are trying to find L. So L is under root of D square minus R square, right? So yeah, so what we tried to find out is if two circles of radius capital R and small r, they are separated by distance D, what will be the length of common tangent, right? So that is the common tangent out to the same side, yeah. So that we have found out here. Okay, all right. Now we'll go back to the problem. So let us say this was okay. Again, my circle drawing skills are not legendary. Yeah. So this was one circle, and okay, let us say this was a common circle, right? This was a common circle, and this was a tangent, let's say, and we have the third circle. Third circle is this one. Yeah. All right. So for now, we'll ignore the third circle. We'll have these two. So let us say this was R. So basically, yeah, this was R and this was X. Let us say this the radius of the common circle is X, right? So this is R again. Now what will be the length from this point to this point? This point to this point will be, first of all, it should be D square minus R whole square, right? This, so this point to this point should be equals to, here D is R plus X, right? R plus X square, and this is R minus R, so this is R minus X because the smaller circle is of distance X, right? Yeah. So this should be equals to 4Rx, right? 4Rx under root, yeah. So 2 under root Rx, right? Now we'll also similarly we have this particular, so like this common circle and the smaller circle. Smaller circle has a radius smaller, so we will have this length. So like this point to this point, following this example, it will be 2x smaller, right? Right? Yeah. So we have these two lengths. So this is 2 small xr, sorry, 2 root x smaller, and this is 2 root capital R x, right? So we have these two lengths. Now let us do this. So this was the bigger circle. Again, this was the common circle. Common circle I will draw in a separate color. So this was the common circle, right? And let us say this was the common tangent. Yeah, common tangent, and this was the smaller circle, right? Now again, this length was R, so this is also R, right? And this is X, right? And this is again X, and this is R, right? This is R. So let us ignore this, let us say this triangle, yeah. So let us see, we again have these two circles which are separated by themselves with a distance is D, that is R plus 2x plus R, right? So for in from this diagram we say that the distance between these 2 points, so this point and this point, should be equals to R plus 2x whole square minus R minus R square under root, right? So now let us calculate this. Yeah, if we calculate this, it will be, first of all, r plus r whole square plus 4x square plus 2 into r plus r into 2x, right, minus r whole square. Yeah, under root of this whole thing, and you calculate this. First of all, these two will turn out to be 4rr, right, and we have 4x square here, and we have 4r plus rx, right. Till here we have, now under root is obviously there, so we will take 2 for outside first. This all this term have 4 in common, so we'll take 2 outside first, and this is r plus x square plus rx plus rx, right. So we have this in this particular term. Yeah, all right. So now that we have these distances, so one distance is this, right, and other distances are what, we have these two distances, right. So this distance and this distance, so if we add these two distances, we will get the third distance, right, this one. So we'll try to do that. Okay, yeah. So let us say we have 2 under root of, we'll write this distance first, right. So this is rx plus x square plus rx, right. So rx plus rr, this should be equals to 2 into rx plus 2 into xr, right. All right, first of all, this 2 gets cancelled from everywhere. Now we have to square this whole term, right. If we square this, what we get is, first of all, this term gets like this. Left side is straightforward. What about right side? Right side becomes rx plus xr plus 2 rr x square, right. Write this. First of all, again, now these terms will get cancelled. This rx, this xr will get cancelled, right. So now we have x square plus rr equals to 2x into r, right. So what we have here is, we can take this 2x square root of r this side, and we will have this equation like this. Now you see, this is straightforward. X minus under root r whole square equals to 0. That means what we have here now is x equals to under root of r. So we have reached this stage finally. So we have calculated, we have found the formula for the radius of the common circle. Yeah. So now we have this, we'll revisit our problem. So our problem was this, right. So here we have this radius should be equals to under root 9 into 4. This should be equals to 6, right. So this is 6, this is 6, this is 9, and this is 4, right. So we add all of them up, it will turn out to be 9 plus 6 plus 6 plus 4, right. So this is simply 25. So these circles need to be, so the first two circles, that is these two circles need to be apart by 25 centimeter in order to accommodate the third circle, which is tangent to both these two circles as well as this common tangent, and has maximum size possible. Okay, hopefully I can make you understand. I could have made this simpler for you, right. uh, in that case, leave a like, comment in the video, and share and subscribe if I am adding some value to you. Thank you for watching this one. We will cover more interesting topics in upcoming videos. Okay, bye for now.